1997-98 was the great big El Nino event, the biggest one on record. There's been generally a marked increase since 1994 in the overall level of activity. The Atlantic has warmed up distinctly, and this is Isaac, taken just before it made landfall on August 28th. Sea level. If there was one thing that you want to look for to convince yourself that global warming is happening, sea level would be it. This is the record since late 1992, when NASA and the French launched a satellite called Topex Poseidon to measure the sea level to millimeter accuracy on a global basis. Prior to that, we had measurements of sea level at coastal regions and at islands, but not really true global sea level. So this is the true global sea level record, and you can see some wiggles here. There's a straight line that's been fitted to this. In the 1997-98 El Nino, sea level tends to be a bit higher. In this time here, in 2008, it's a bit lower. That was a La Nina, and there's a spectacular event in here that turns out to be rather interesting, a unique event, and it turns out this corresponds to a whole host of flooding events that I'm going to talk about a little bit on land in these regions here. And in particular, there was extensive flooding in Australia. You may have read about all of the flooding that occurred in Queensland, and there was so much water dumped on Australia that it was equivalent to taking 2.5 millimeters of water out of the global ocean and dumping it on Australia. Just absolutely incredible. This is the first time we've had an example of anything like that in terms of how much water has actually gone out of the ocean temporarily onto the land. In Venezuela and Colombia, there was extensive flooding. But in Venezuela and Colombia, after a couple of months, the water tends to make its way back into the ocean again. In Australia, it just sits there. There's a big lake called Lake Eyre that forms because Australia doesn't have much of a river system, and so it doesn't run back into the ocean. So sea level is rising. I should go back. Sea level is rising for two reasons. One is because the ocean is expanding. We can measure the temperatures of the ocean, and so it's expanding. And secondly, there's melting of land ice, Greenland, and glaciers on land. And up to 2003, that contributed about 40%. Since then, it's contributed even more. So there are two things relating to the warming planet that are contributing to this. And so there's been an increase of about 2.2 inches through this record here. And so the overall rate of increase is just over a foot a century. That's the current rate of increase of sea level. So this has impacts in coastal regions, not too far from here, potentially. Glaciers. What about glaciers? Glaciers are generally melting. You've probably seen these kinds of things before and after. But I've got a little movie here I'd like to show you because it's very hard to get good pictures of climate in action. But a colleague of mine has produced some, and let me show you this movie if I can. Stupid thing. Go. Let's see. So this is what James Baylog did, and you can see the website here, was to put out cameras in association with National Geographic at a number of different places, and took pictures every 20 minutes, I think it was, and as long as there was sufficient light. So in the middle of winter, it may not be taking many pictures. Some days it misses out. But you can see these glaciers, and this one over here, flowing into this region. And you can see these glaciers actually in action, and then, sort of calving events as big chunks break away. And gradually, these glaciers are retreating. And so you can see the timeline down here for this. This is about a 2-year timeline. And he's put this together in a way which shows you the retreat of this particular glacier in particular. And then let it run a little more.
Isn't that 1.5 years? 1.5.
Yeah, 1.5 years. It's not that long. So, and pieces of this are missing, as I say. In the wintertime, you probably don't have that many. So there's some fairly large jumps in there. Let's see. So that's climate change in action. Then we come to the Arctic sea ice. I mentioned, and I just put this on here before, a day ago, indicating 2012 is already below 2007. 2007 surprised a lot of people. It was a big jump down, 22% lower than the previous low, which was 2005. And overall, there's been more than a 40% decrease in the summer sea ice in the Arctic. And this is a map of the current sea ice and where it would have been normally under these kinds of conditions. And so the projection is that, by the 2030s, there may not be any sea ice left in the Arctic. And that has a whole lot of ramifications in a number of different ways. I want to talk a little bit about extremes, because this is how climate change is actually manifested more than anything. So with a warming climate, there's more high temperatures and heat waves, there's wildfires and other consequences, and there are fewer cold extremes. And I've already mentioned, the increases in drought, the heavy rains and the floods, and changes in storms. A key point about this is that the environment in which all of these events are occurring is different than it used to be. In particular, over the oceans, it's warmer and moister than it used to be. And as a result, it rains harder, there's more energy that flows into the storms develop differently than they would have, and we can do simulations like this with climate models or weather models at NCAR. And show how these storms would have differed simply because the environment in which these storms form has changed. Jim Hansen published a paper just a short time ago indicating for June, July, August, the summertime in the Northern Hemisphere, the summer in the Northern Hemisphere, what the distribution of temperatures looked like. So this was his reference period, 1951 to 80, and dividing it up into thirds. This is sort of a bell-shaped distribution as to what these values look like relative to the normal. And then if you compare 1981 to 91 with this period, you can see a shift into more high temperatures. The following decade, a further shift. The most recent decade, a further shift again. And so whereas there were 0 values above this value number 3 here, which corresponds to 3 standard deviations, for those of you who know what that means, never mind, it's, you don't expect more than about, 0.1% exceeding that kind of value. Now there's something like 10% of the values are exceeding that value, showing a clear indication not only of the changes in the average, the warming that has occurred, but also a big growth at the very high end. So that this value here is now a bit lower than this, and there's more spread. In other words, we get more really high temperatures than we used to around the world. So that's the nature of the climate change that's going on. Now, in the United States, there's an analysis of a colleague of mine by named Jerry Meal, and he published this work looking at the relative frequency with which records are being broken in high temperatures and low temperatures. And for an unchanging climate, you would expect that these would be about 1 to 1. As the climate record gets longer, you still expect to break records. They become rarer and rarer, but they should be balanced between the warm and the cold side. And in fact, in the 1960s and the 1970s, it was weighted towards the cold side. But then in the 80s, it moves back, and 90s, the 2000s, it was up to around 2 to 1. And in 2010, it was about 2.3 to 1. In 2011, 2.7 to 1. And for the first 5 months of this year, it was actually at a ratio of 9 to 1. The amazing thing is that in spite of all of the heat we've had this year, there are still some places that are breaking cold temperature records. And in this case, they were all in the Pacific Northwest. And of course, that relates partly to the nature of the atmosphere. There are waves. In one place where it's warm, there's someplace else which is cold. One place which is wet, someplace else is dry. And this is one of the things which, this kind of complexity is one of the things which can lead to confusion. So some examples, 2010, in August of 2010, there was a tremendous heat wave in Russia, These are pictures from space of wildfires. You may be able to see St. Basil here, hidden in the background, and record high temperatures, more than 10 degrees Celsius, 15 degrees or more Fahrenheit above normal for over a month period, about a 6-week period. In India, there was extensive flooding. Pakistan, in late July into early August, there was extensive flooding. The major Pakistan floods, several 100,000 people dislocated as a consequence of that. I mentioned before the heavy rains in Australia. These were highlighted mainly in Queensland in December and into January, where there was extensive flooding in this part of Australia. And if we look at what went on in 2010, this is a picture of the sea surface temperatures in June, July, August of 2010 relative to a base period of 1951 to 1970. So this turns out to be a key for telling you where these kind of events are occurring. In this time, there is a La Nina event, so it's relatively cool in the tropical Pacific. That tells you where the action is not occurring. But there was an El Nino before this, for the 12 months before, before this, from March of 2009 to March of 2010 was an El Nino, and it left behind all of this warm water over here in the Indian Ocean and in the tropical Atlantic Ocean. So it was exceptionally warm in these regions, and in fact, it was record high temperatures in the northern Indian Ocean, in the Bay of Bengal and the Arabian Sea. There were also record high temperatures recorded in the Gulf of Mexico in August of 2010. There were record high temperatures in the Caribbean in September of 2010, and October was the second highest on record. There were record high temperatures in north of Australia, just all of this region north of Australia here, in December of 2010. In September, October, November of 2010 was the second highest on record. And so some of the consequences then were that there were Pakistan floods as part of the monsoon rains that pick up the moisture from the Bay of Bengal and the Arabian Sea in this case, and dump it down in Pakistan and also in India and China. It was the second most active hurricane season on record. The Colombian floods I mentioned before, and in Venezuela, tremendous flooding all throughout this period from August through to December. And then in Australia, the Queensland floods in December and January in particular. And so there's a direct relationship here, and the fact that these sea temperatures are so high and breaking records is because there is a human influence that has warmed up the global oceans. Then we went into 2011, and we had the extensive flooding along the Mississippi. These are pictures from space. And we had the major tornado season. I don't have time. I've got a nice tornado movie, but I don't have time to show it. And one of the things that you can observe, though, is that in 2011, it was the third time in, 20 years, when we had a 1 in 500 year event.
Yeah, right.
They're no longer 1 in 500 year events, right? They're 1 in 50 year events or something like that. And the fact of the matter is that the climate has changed, and what used to be a 1 in 100 year event is now a 1 in 30 year event or something like that. And the Corps of Engineers is not fully caught up on that kind of thing. In Arizona, they had the biggest fire ever, and there were also extensive fires in Mexico. And then there was major drought in Texas, the biggest fire ever in Texas. Over 14,000 acres in Bastrop State Park. About 600 homes were destroyed around the end of September 2011. And in Dallas, they had a record number of days over 100 degrees. June, July, August 2011 was the hottest on record in Texas. This is the pattern of what 2011 actually looked like. It's quite striking, and there was a La Nina in effect, which had large control over the patterns of weather across the United States. It meant there was a storm track right across here, up into the Ohio River Valley, and right right through all of these states here, labeled 117, were the wettest on record in 117 years, and Texas was the driest on record. So you don't have to go that far to find floods and droughts. In the case of last year, this huge contrast. And in both cases, they're worse than ever on record before. It was also very wet up here. You may remember there was very heavy snows in the northern Rockies, especially, and there was flooding along the Missouri as well in the very late springtime. This is what the actual record looks like. The value is way down here. This is sort of New England, the wettest value on record for these states here. And then we come to this year. There was a very mild winter. It allowed a lot of bugs and viruses and things that would normally get killed to winter over. In consequence, maybe West Nile virus, right? A major outbreak occurring at the moment. This was March. There were something like 15,000 records broken across the country in March, and some people colloquially referred to it as June in March. June temperatures were occurring in March. This actually had created some problems in the northern states, because then in April, when it got a bit cooler and went back to a more normal April, a lot of trees had blossomed, and a lot of fruit, like cherries and so on, all of the buds were destroyed by the cool spell in April. So Mother Nature sort of faked them out in that regard. But the point I want to make about the warmer winter had a whole host of advantages, right? There was less snow removal costs, there was less, probably people had less colds. Many people enjoyed not having to shovel a whole lot of snow and worry about skidding around on snow and ice. So it had some upsides in that regard. The heating bills are probably a lot less. June temperatures are still familiar. We get them in June, we just don't get them in March. It's not the sort of thing that causes us to worry perhaps as much as it should. But what happens if we have those kind of records occurring not in June, not in March, but when we do get to the summertime? And of course, that's actually what happened subsequently. And so there was record low snowpack in the Colorado Rockies as of the 1st of May this year. So there was a drought in the southwest that had been developing all through this year, and there was no snow as of May in the mountains. As a result, the sun is coming in with the summertime developing. It has nowhere to go in terms of firstly melting snow or being reflected by the snow. And secondly, once the snow is melted, there's all this water usually lying around, and the heat goes into evaporating moisture. Instead, it all goes into raising temperature and drying things out so that they tend to dry, and next thing you know, we've got major wildfires developing. And so there was the Waldo Canyon fire down in Colorado Springs, where 346 homes burned, and the High Park fire, 259 houses up near Fort Collins. And I just happened to have, this is a picture of boulders, it turns out, and there was a wildfire about a mile and a half above NCAR, my home institution. I don't know whether you can see it on here. That's the Mesa lab where my lab is, and it was closed for 2 days because the air quality was too bad and we couldn't run the computers. But we were never seriously under threat, but the air quality went down substantially. So there were a whole host of wildfires, and of course they're still going on in different parts of the country, further north in Wyoming and further west. One of the nice things was that in the middle of July, we actually had a fairly good rainstorm that came in as a part of the southwest monsoon that sort of saved Colorado from worse things happening. But you know, the wildfires in Oklahoma and other places have continued. And one of the natures of the problems is given here. This was a survey that was done after June, when all of these wildfires had taken place. And there were 258 segments on television that had reported on the wildfires, and 1.6%, had had mentioned climate. Only 4, only 1.6%. For print articles, it was 6%, 8 articles out of 135.
Why do you believe that?
This is terrible reporting, and it did improve in the first part of July. And as Rhoda mentioned, I was actually on PBS NewsHour in early July, and also on CBS News, and there was some reporting relating these wildfires to the drought, and a little bit relating to climate and climate change, but still, it has been, this whole business has been severely underreported. And so by the time we get to July, this is what January through July looks like in terms of the record warmest in many places throughout the country. And now it's spread east of Colorado as a whole, and of course this is the getting into the Corn Belt in particular, and so it has major consequences for corn and soybeans. Now, one of the perhaps nice things that you should ultimately hear about after Isaac goes through, Isaac's headed right up through here, and a lot of this territory here is suddenly going to get very wet. But it's too late for the corn crop for the most part. In fact, it probably hinders many people from actually harvesting the meager crops that they do have. But this is the hottest on record for this period. In fact, the last 12 months are the hottest on record. And what I did was to put together yearly values actually going from starting in August and going through the subsequent July in order to capture what's happened. And this is the value right here for the last year. And then you can see the fluctuations. And you can see in general, it's been warmer in the last 20 years or so than it has previously. But one of the periods that previously was very warm, especially in the summertime, was in the Dust Bowl years in the 1930s. And for the first time now, July of 2012 beat out July of 1934 and vanquished the last record from the Dust Bowl. So that is now taking place. So this is what has happened this year, and it certainly doesn't mean it's going to happen this way in the future, but this is the sort of thing we expect to happen with climate change. Now, it hasn't been this way, of course, in other parts of the world. In fact, as I mentioned before, the very nature of the atmosphere, we have waves in the atmosphere. If it's anticyclonic, settled weather in one region, it has to be cyclonic and very wet somewhere else. It was the wettest spring on record in Britain. It was second wettest summer on record in Britain. Southern Russia had major event with very heavy rains, and 172 died in this particular event. Southern Japan had, these are from NASA, very heavy rains in the southern island of Kyushu in southern Japan with tremendous consequences. And in Beijing, there was a major storm with, I don't know how many people died. They said something like 70, but who knows whether they're telling the truth. I use this slide just to introduce the fact that at my institution we do a lot of modeling. We have to simulate all of these processes, the interactions between the atmosphere and the ocean and the land, and the hydrological cycle, clouds, and we divide the atmosphere and the ocean and the land up into layers and run these things on the biggest and fastest computers that we can find. When we do that, one of the fun things about being a climate scientist is that you can actually play God. You can change things. And so this is the this is an estimate of the observed temperature record. It's slightly dated now, but nonetheless. This is what happens if we run our climate models without the observed increases in carbon dioxide in the atmosphere and the other greenhouse gases. So there are some changes included in here. There are estimates of effects from volcanoes, and those are these downward spikes that you see in here. These are volcanic eruptions, and there's some estimated effects from changes in the sun. And the changes in the sun are estimated to have produced a modest warming in the first part of the 20th century. So this is the estimate of what would have happened if we hadn't change the composition of the atmosphere. And if we run the same model with the observed changes in greenhouse gases, some aspects of pollution, and changes in ozone, then we get this. Now, what is shown in here is an average of 4 runs, and there's a gray bar here and a pink bar here, which is an indication of sort of the level of natural variability that occurs because of the weather and the randomness and things like El Nino and stuff like that. And so we can reasonably simulate the observations with this model. So here's a couple of volcanic eruptions that, they're not done perhaps as well as they might be, and we've got better models now that do this better. But the key thing to note here is that most of what was going on up until maybe about 1970 could be regarded as largely natural. And then in recent times, this is the gap that's associated with the human influence on the composition of the atmosphere. A quick one?
Yeah, if you just run out the constant state of how bad things get like 10, 20, 30 years ago. No change, but just the path that we're on now.
Into the future?
Yeah.
Yeah, so this is talking about attribution. I mean, we do have that. I'm coming to that now. I do actually have a movie that I can show you being run out into the future, but I'm not going to show it in the interest of time. This is what it looks like at the end of, in 2100, and this is relative to 1870 to 1899. And so we run it through the 20th century with the actual simulations, and this has been run multiple times. So this is an average curve down the bottom here, so it cuts out the main fluctuations. And then going into the future, we've run it in a number of different ways. A1B is a run which is probably reasonably conservative, but more or less realistic, out to about 2050. And then it assumes that we reduce the amount of carbon dioxide going into the atmosphere fairly substantially. A2 puts a lot more carbon dioxide into the atmosphere in the second part of the 21st century. B1 is a very optimistic scenario which says we don't put any more carbon dioxide into the atmosphere much. And this commitment says this is what would happen if we completely stopped any carbon dioxide emissions into the atmosphere in a completely unrealistic way. It would still warm about 1 degree Fahrenheit, as it turns out, simply because the oceans are slow to respond. So when we look at this pattern, we see that the biggest warming is in the Arctic, and so this relates to the Arctic melt. The second biggest warming is over land compared with the oceans. And there are 2 spots, one right here and one down here, which actually, in this particular run, did not warm up. This little spot here is related to changes in the ocean currents, changes in the Gulf Stream. And in fact, it was the idea behind this kind of thing which led to a movie called The Day After Tomorrow, and somehow they converted this into an ice age in a completely unrealistic fashion, a science fiction way. But the odds are that there may be a bit less warming up in this part of the North Atlantic because of changes in the currents. And down around Antarctica, there is very, very deep mixing, and there are parts of Antarctica which will be slow, or part of the polar oceans which will be slow to warm. And Antarctica itself will be very slow to warm because it's high, white, and cold. One of the projections, just for North America, relating to extreme heat, I've just shown you here, is that for what are currently 1 in 20-year events, by the end of the century, are estimated to be about 1 in every 2-year event, or something like that. That's the kind of change that we're projecting to occur. This is the projections from the models in terms of the overall precipitation patterns. It suggests that it gets a lot drier in the subtropics, places which are already arid or semi-arid, where all the deserts occur, over the oceans and over the subtropical continents, but it increases in rain at high latitudes. That's because at high latitudes the atmosphere can hold more moisture when it warms up, and as a result, especially in the wintertime, it can snow harder and it can certainly rain harder. But then, and in the monsoon trough also, there can be increases in rains. Now notice this extends well into the southern parts of the United States. It really affects the Mediterranean area in major ways. When you look at soil moisture, however, it dries out most places. And the difference between this, even in places where there's increases in precipitation, there's less soil moisture. This is because there's an increase in evaporation. This relates to what I said before about droughts being more likely as we go into the future. There's another effect which comes into play here. In addition to these changes in average precipitation amount, there are changes in the intensity. The rains, when it rains, it pours, it rains harder, it runs off more readily, and so it doesn't soak into the soils, and this also has consequences and means that it's going to be much, much more difficult to grow stuff. And plants, ecosystems, will have a much harder time as we move into the future. So I showed some cartoons before. I went well on these things, but this is the sort of thing. I'm mostly finished with what I regard as being basically the facts behind this problem. And so I thought I would say a little bit about, what should we do about this? What are the future prospects? And the scientific view that came especially out of Europe was that we shouldn't increase the global mean temperature by more than 2 degrees Celsius, about 3.6 degrees Fahrenheit. It's already increased by 0.8 degrees Celsius, about 1.4 degrees Fahrenheit. But to achieve that would require very deep cuts in global emissions. This came from the Copenhagen Accord in 2009.